Alrighty, here we go. Now we get to get into chemistry. So our other review was kind of mathy, and this is going to feel very chemistry. So we are going to look at nomenclature, which is naming types of compounds and then writing the formulas of those compounds from their names. You're expected to be able to do this unaided, so this chart is not on in your information booklet, but hopefully we'll do enough of these that by the time you're writing your midterm or something that this is just second nature. So we're going to start with type 1 compounds. Type 1 is a binomial compound, meaning two elements, and it's going to be composed of a metal and a non-metal formed by an ionic bond. And the key thing that's going to make this a type 1 is that the metal, the cation, so the one with the positive charge, is only going to have one potential charge. So you're going to name these by naming the cation first with its elemental name and then changing your anion's name, ending to an "ide." What do I mean by having only one charge? Well, if you go to your information booklet and you turn to your periodic table, it's got metals on the left and kind of into the right as well. So there's a step line here. So if we were to put the step line in here, to the left of the step line is all of your metals, and to the right is all of your non-metals. So when we look at these metals to the left, there's a few of them that only have one number up in the right-hand side. The upper right-hand corner, this is your combining capacity or your potential or your charge. So lithium has a +1 charge, meaning that its outer valence shell is lacking one electron. So what happens with the ionic bond is that lithium will react with something that has an excess electron or has an electron that it can give. So an ionic bond is that the lithium is going to take that electron and fill its outer valence shell, and then they will be bonded in a ionic bond. So lithium has a +1, beryllium +2, scandium +3. All of these are type 1s because there's only one number in the top right hand corner versus something like titanium, which has 3 different potential cation charges. So titanium could be +2, +3, or +4, depending. So what we're going to do is we're going to practice naming some type 1s and writing their formulas. So type 1 is going to involve something like an aluminum, so elemental name, and then oxide. That's how you know that it's a type 1, is it's just the name, oxide. So when we're trying to write its formula, what you have to figure out is what the charge will be. So because it's type 1, there'll only be one potential charge. So if we look for aluminum, it's over here in green. Aluminum has a +3 charge, and that's all that it can have. And then we look up oxygen, and oxygen can only have a -2 charge. Now, in order for these two to make an ionic bond, they want to complete their valence shells. So what happens is that you have to gain and lose enough electrons that everybody's happy. So what we want to do is have an overall charge of 0. So since this one has 3 spots for electrons and this one has 2 electrons to give, we want to change these into -6 and +6, so that the -6 +6 would give it an overall neutral charge. The way that we do this, you can think about creating or finding a common multiple, or simply do the crisscross method, which is that you take the charge on the oxygen, you bring it down on the aluminum, and then you take the charge from the aluminum and you bring it down on the oxygen. And then you just make sure that these are in lowest terms. So if you double check, if I have 2 aluminums, that'll give it a +6 charge. And if I have 3 oxygens, that would give it a -6 charge. So this compound has an overall 0 charge. So let's do the same thing with calcium bromide. Calcium, if we look for it on the periodic table, calcium has a combining capacity or a cation charge of +2. And then bromine, which is called a bromide in its compound, is a -1. So again, we can just do the crisscross method and say it would be calcium 1, and then it would be bromine 2 to make calcium bromide. Awesome. So now what we'll do is go the other way. Let's name from a compound. So magnesium iodide. Oh, I just said it. So this is magnesium. And and you just give it its elemental name, and then iodide. You just change iodine to iodide. How do I know it's type 1? Well, if I go and I look up magnesium, magnesium is right here, number 12, and it has a charge of just +2. So I know it's a type 1 compound. All right, maybe pause the video and give this one a go. So for this one, also type 1 because it's calcium, which we already know can only have a +2. So I'm just going to call it calcium. And then calcium was with oxygen. And you're going to change that ending to just oxide. Okay, there we go. Let's move on to type 2. So in type 2 compounds, the key thing is that we're going to look at those ones that do not have just one cation charge. So we're going to be looking at a metal and non-metal again, but the metal can have multiple charges. So this is going to be mostly transition metals or metalloids. But to name them, what you do is you keep the same elemental name for the cation, but then you include the charge as a Roman numeral in brackets. And then the anion, you just change the ending to "ide." So for example, if you have copper and chlorine, copper, if we look on our formula sheet or on our data package or information booklet or whatever, periodic table, copper has two choices, +1 or +2. So then you have to look at this and go, okay, is this a 1 or a 2? Well, how would you figure it out? What you'd have to do is look at the charge on chlorine. Chlorine has a -1 charge if you look it up on the periodic table. And so since there's no subscripts, that must mean that it was a copper +1. And so this would be copper 1 chloride. And then they would have done the same thing with mercury. This would be mercury 2 oxide, lead 4 chloride. But let's look at that in a little bit more detail. So naming type 2s. If we have lead 4 phosphide, again, you'll know it's type 2 because there's something in brackets, a Roman numeral. So because they've told us it's 4, that means it's lead, Pb, and that it's 4+. Now, if anybody isn't comfortable with the fact that lead is Pb, and then it would be really hard to find on your formula sheet, I just want to point out that there's a second page in your information booklet, and it has all of your elements named alphabetically. So if I was to look for lead, I could see that lead is Pb, and it's element number 82. So if I went back to my periodic table, I could look up element number 82, there's lead, Pb. And then I know that it could be a +2 or a +4, but this tells me that it's a +4. And then I'm going to look up my phosphide, which is phosphorus. So phosphorus should be over here on the right-hand side. There's phosphorus, and it has a combining capacity of -3. So then if I was going to give its compound formula, it would be Pb3P4. So again, that crisscross method. And that makes it a +12 and a -12. Okay, try iron 3 chloride. So iron is Fe. I know this is Fe3+. Chlorine I know is 1-. So then this would be FeCl3. Sweet. So now let's go the other way around. If I need to name from the formula, what would I do? Well, I know this is Fe3N2. So if I was going to write this with its charges, this is going to be Fe2+ N3-. You're undoing the compound, right? So to undo the crisscross. So if this is Fe2+, I just want to double check that iron can be a 2+, because sometimes the subscripts will get simplified. So since iron can be a 2+, then I would say that this is iron 2 nitride. Awesome. Okay, one more. See if you want to give it a go. So for this one, we've got SN, which is tin. Oops. And let's first of all figure out what the charges are on here. So we've got tin. If I undo the crisscross, I've got tin 2+ and sulfur -1. But then I want to go and double check that that's possible. So if you look here, sulfur actually has to be a -2. So something's happened here. And then if we also look at tin, SN, where is SN? There it is. It's number 50. Tin can be either +2 or +4. So if I look at here, +2 would have been possible, but the sulfur can't be -1. So if I make the sulfur the -2, that makes the tin a +4, right? Because they have to maintain that balance. And so when you do the crisscross, everything sort of that can get simplified does. So since this would have been SN2S4, it gets simplified to SNS2. So they're a little bit tricky. So this one would be tin 4 sulfide. And I will mention, depending upon the resource you look at, sometimes sulfur is spelt with a PH and sometimes sulfur is spelt with an F. I think it's a maybe American Canadian thing, but we will be spelling sulfur mainly with a PH in this course, but you every once in a while might see an F. So don't be worried, it means the same thing. All right, so now what you want to do is you want to go to your practice and do the first types of questions.